the string class. Because strings are so common, we do not have to use the new operator to create a string object. This is a special syntax that only works for strings. So whenever we instantiate a string object, we just use the double quotes and then put the characters that we want inside of the string. And this is the same thing as using the new operator. Now this only works for strings. It's just a special syntax that Java created specifically for strings. Each string literal in closed and double quotes represents a string object. Once a string object has been created, neither its value nor its length can be changed. Therefore, we say that an object of the string class is immutable. However, several methods of the string class return new string objects that modify the version of the original. However, several methods of the string class return new string objects that are modified versions of the original. It is occasionally helpful to refer to a particular character within a string. This can be done by specifying the character's numeric index. The indexes begin at 0 in each string. In the string hello, the character H is at index 0 and O is at index 4. See stringmutation.java. So in this program, they created a string called phrase, and that phrase is change is inevitable. And then they created 4 object reference variables, mutation 1, 2, 3, and 4. They print out the string phrase, then they print out the length. Then they invoke concat on phrase and assign it to mutation 1. Then on mutation 1, they invoke to uppercase and assign the result to mutation 2. Then they take mutation 2 and replace E with X and assign that to mutation 3. And then mutation 3, they invoke substring and they assign the result to mutation 4. We'll talk about these methods. I'll go ahead and do some examples using these methods. They print out the results, and then this is the output. Here are a list of string methods that are in the book. I'm going to do an example and I'll show you how to use all of these. Just looking at this, the first one is the constructor. So this is the method that gets called whenever we first instantiate an object. And then we have a method called char@. We pass in the index of the character that we want within the string. Compared to, this will compare one string to the other. It's going to return a negative value if the object is less than, a 0 if the object is equal to, and a positive value if the object is greater than. So you would invoke this on a string and then you pass in another string that it's going to compare itself to. Concat, it's going to join the original string with the string being passed in. It's the same thing as using the plus operator, except it's going to return a new string that contains the concatenation of these two strings. We have the equals method. You basically pass in a string, you're comparing yourself, it's going to return true if they're the same string, return false if they're not. Then you have equals ignore case. It's going to ignore case when it does its comparison. You have length, which is going to return the number of characters in a string. Replace, so the way this works is you put in the char that you want to replace, and then you put in the new char that you want to replace it with, and it's going to create a new string and return that new string from this method. The next method is substring. So you pass in the offset and the end index. Now the end index is going to be the end index minus 1. I'm going to go ahead and talk more about this method because it's important to understand this one. Then we have lowercase, which returns a string but in all lowercase, and uppercase, which returns a string in all uppercase. The API documentation also has other methods that are very useful. Within the API documentation, you can find other methods that weren't mentioned inside the book. There are some good methods in here. One method I like to use is trim. What the trim method does, it returns a string whose value is a string with all leading and trailing spaces removed. It's basically going to return a string with the white space that's before and after the string all removed. Another good one is blank. Returns true if the string is empty or contains only white space. And another one is empty, which is another good one. Returns true if and only if the length is 0. Another method I like to use on the string class is format. Notice that this method is static. The format method works just like the printf, except it's going to return a string. Now, since this method is static, we don't need an object of the string class to invoke this method. We call the method through the class name. So like I just mentioned, the string class has static methods. A static method is a method invoked through the class name, the blueprint, and not the object. So before I do any coding examples, I kind of wanted to give a visual aid of what's going on whenever we use a string object. So up here, I declare a object reference variable that's going to hold a string. So that declaration is actually happening right here. This is my declaration. And all this declaration does is tell Java that this object reference variable is going to point to a string. On the other side of the assignment operator is my instantiation. Now Java has a special case for strings where we don't have to use the new operator, but for all other objects, we're going to call the constructor using the new operator. And that's going to look like this. So here is me using the new operator with the constructor. The constructor is a special method that is going to set up the object. So it's going to exist in the blueprint. So in the blueprint, we're going to have a constructor that's going to tell Java all the things that we need to do in order to instantiate this object. It's going to be doing things like setting variables, initializing data. So Java is going to use this constructor to put an object into memory. So once this instantiation happens, we'll have an object inside of memory. We'll just say it's right here. It's important to remember that string objects are immutable. So what that means is once we've created that object, it cannot change. So there's no way for me to change this object here to have it hold something other than Michael. So since this object is immutable, whenever you invoke methods through the object reference variable, the string class is going to create a new object that is going to be a modified version of the original. So here you can see that I'm invoking two uppercase on name. So what's going to happen is Java is going to look up this method in our blueprint. It's going to see the method in the blueprint, and the method is going to have instructions on what to do on that object in order to make a new string object that is in uppercase. So this method is actually going to create a new object in memory. So we'll say the object is right here in memory. Now there's a new object in memory that's going to be a modified version of the original string, but in all caps. Now this two uppercase returns a string. So what it's really returning, it's returning the address of where this new string object is located. So if we wanted to have a reference variable pointing to this new string object, we're going to have to actually assign the invocation of this method to a new object reference variable. So if we wanted to do it, it would look something like this. So now I'm assigning the result of two uppercase to this new object reference variable called upper. So now upper is going to point to the memory location of where this object is located in memory. If I didn't capture this in an object reference variable, after this line is complete, there would be no valid object reference variable pointing to this object in memory. And when the garbage collector runs, it would free up this memory so the system can use it for something else. So another thing I wanted to talk about is what exactly a string is. So a string is actually a collection of characters. If you look at the string, it's my name, but it's my name composed of 7 different characters. So since the string is actually just a collection of characters, the characters are put into a container and they have an index. Here's an example of what the string actually looks like. It's simply just a container of characters. So this string has 7 characters and each character is at a specific index. So the first index is index 0, the next one is 1, and so on. If I wanted a char out of the string, I would make a char variable to hold the character and then invoke a method to grab a character from the string. So I've created a char variable C and I'm invoking the method charet on this string. So charet index 3. So what's going to happen is Java is going to use this index to look up the location of my string at index 3. At index 3, I have an H. So that means after this line is complete, that C is going to have an H in it. Now, if I were to pass something that was outside of the range of my string, let's just say I passed in a 7, there's nothing at index 7. So what's going to happen is this will compile and run, but whenever I get to this point, I'm going to have a runtime error because when Java looks up the character at index 7, it's going to see that my string isn't long enough and it's going to throw an exception and the program is going to stop. It's important to remember how characters in a string are organized. So the first character is going to be at index 0 and the last character is going to be the length of your string minus 1. So the length of my string is 7, and if I were to subtract 1 from that, it would be 6. So my highest index is going to be my length minus 1. The other thing I want to talk about are static methods. So right now I have a string object reference variable that's holding a string. This string is instantiated and is actually inside of memory because here's my instantiation. So name is pointing to this object in memory. So since name is pointing to a string object in memory, through the name object reference variable, I can invoke methods like length. When I invoke length through the name object reference variable, Java is going to look up this method inside of my blueprint and it's going to see like what exactly it needs to do in order to use the method length. And what's going to happen is it's going to use this object in memory and count the number of characters inside of this object. So the result of this, I'm going to get 7. Now there are some methods that are static. So what static means is I don't need an object in memory in order to use that method. So one of the methods that are static in the string class is format. So the way a static method works on the string class is when you want to invoke that method, you're going to actually use the name of the class. So here's the name of my class and here is the static method that I'm invoking, which is format. So the way this is going to work is format is a static method. So Java is going to look up this method, see all the details of format, and since it's static, I have to invoke it through the class name, but it doesn't need an object in memory in order to do any work. This format method is just going to give instructions to Java on what needs to occur in order to use this method. But since I don't need an object in memory, I can just go straight through the string class and invoke the format method and do whatever work it tells me to do within the format method. Now the format method works just like the printf method. So you're going to have a string right here with some flags we'll just say like %d, and then you'll pass in a value to it. We'll just say like a 5. And instead of printing something out to the console, what this is going to do is generate a string that holds the result of whatever is inside of the format. So if you wanted to capture this object, you're going to have to create an object reference variable and assign it to the result of this format method, because this format method is going to create an object in memory and hold a reference to it. So we need an object reference variable in order to capture this reference to this object in memory. We didn't need an object in memory in order to invoke the format method. Whenever we invoke the format method, we're going to create an object in memory. And if we want to capture those results, we're going to have to make an object reference variable to hold the reference to that object in memory. If we don't capture the results of this object reference variable, whenever the garbage collector runs, it's going to free up this memory. So I created this class to demonstrate some of the methods from the string class. So the name of my class matches the name of my file. I'm going to go ahead and create some string variables. So the first one I'm going to create is the traditional way where I'm going to assign an object reference variable to a string literal. And the second way I'm going to create a variable is I'm going to use the constructor and the new operator. Using the constructor and the new operator for a string is normally not done because we have this easier syntax to instantiate a string object. So it just kind of makes less sense to use this because it's more typing. But these two work exactly the same, so I'm going to go ahead and print out these results. So I'm printing my 2 string object reference variables, so I'm going to go ahead and compile and run this program, and there are the results. So a string is an object. So what exactly does that mean? That means it's not just data. There's characteristics and behaviors associated with that. And the behaviors are the methods that you can invoke on a string. If you look back into the book, you can see that they gave you a list of methods that you can use. I'm going to go through all the examples from the book, and I'm also going to introduce other methods from the Java API that I think are useful. So the first thing I want to demonstrate is the 2 uppercase and 2 lowercase. So I'm going to go ahead and invoke those 2 methods on my first name, and then I'm going to print my first name back out so you can see that the object did not actually change. So here I'm getting my first name, I'm invoking the method 2 lowercase, and I'm invoking the method 2 uppercase, and then I'm printing out the first name once more so that we can see that my first name didn't actually change. So the string object is immutable, so I want to print this out so that I can see I still have my original value, which is Michael with the uppercase M. I'm going to go ahead and compile and run, and you can see the results. So 2 lowercase just made everything in lowercase, 2 uppercase made everything in uppercase, but when I print out the results of my first name, it's still Michael. So I'm going to go ahead and demonstrate a few more methods. Alright, so I added a few more lines. I wanted to just demonstrate some of the easier methods. The first one is the char at. Now char at, I'm passing in index 3. Now remember, at index 3 is actually the 4th character because I started at index 0. Then I'm calling length on my first name, length on my last name, and then I'm doing a replace. So I'm saying in my last name, replace A with O, and then the last thing I'm doing is I'm printing out my original values so that we can see the values did not actually change. So whenever I do something like replace, I'm generating a new string. It's taking my original string for my last name and making a modified version of that string. So my last name object is going to stay the same. So I'm going to go ahead and compile and run. And you can see that char at 3 in my first name is H. It's the 4th character because the capital M is at index 0. And then it's saying the length of my first name is 7. The length of my last name is 8. I replaced A with O, so I got the result of my last name, but I'm using an O instead of the A. And you can see there are my original values for my first and my last name. Now, what do you think will happen if I were to call char at, but I would go outside of my range? Now, we talked about this. Now, what's going to happen is in my first name, the very last character is L, and my first name is 7 characters long. But since we start off at index 0, the last character is at index 6. So I'm going to go ahead and demonstrate that. I'm going to put char at 6, and then I'm going to compile and run this program. You can see that there is an L at index 6. So now what I want to do is I want to go past that. I want to go to 7, and we can see what happens. I modified this to 7. Now, since my first name is only 7 characters long, index 7 does not exist in my first name because the last character is at index 6. So let's see what happens when I compile. So it does compile, but let's see what happens when I run. So when I run, I get an exception like right when I try to use that method. And it's telling me that at index 7, we're out of the range of the string. So Java knew at that point, hey, your string is only 7 characters long. There is no index 7. And it just crashed at that moment. So I added a few more method calls. I wanted to test the compare to. So in the first case, I'm comparing my first name to my last name. Second case, I'm comparing my last name to my first name. And then my last case, I'm comparing first name to itself. So if you remember from the description in the book, if first name is considered to be less than last name, then this is going to result into a negative number. If first name is considered to be greater than last name, it's going to result in a positive number. If first name and last name are considered to be equal, then the result of this would be 0. So let me compile and run. And here are my results. So first name name is considered to be greater than my last name is considered to be less than my first name. And when I compared my first name to my first name, I got a 0, so that means they're considered to be equal. Now, the reason why the first name is considered to be greater than my last name is because the first character, they both have a capital M. The second character, my first name has an I, my last name has an A. Now, the lowercase a comes before the lowercase I in the Unicode character set, so that means that a has a smaller value. So whenever Java does any string comparisons, it's actually taking that number from the Unicode character set to do its comparison. So I added the equals method check. So I wanted to check the equals method, and I set up a few different scenarios. So the first scenario is I'm checking to see if first is equal to last, and I'm checking if last is equal to first, and then I'm checking if first is equal to first, and then I'm checking if first is equal to first in all uppercase. And then the last check I'm doing is I'm checking to see if first is equal to first in all uppercase, but I'm calling equals ignore case. So let's look at the results. So first does not equal to last, it returned false. Last is not equal to first, returned false, but first does equal to first. I mean, that makes sense. Returns true. Now, first is not equal to first in all caps. That returned a false. But when I did the ignore case, it returned true. So if I wanted to ignore case, then I would call equals ignore case. And I compared my first name to my first name in all uppercase. So the next example is a concat method. Now, this is a very simple method. It just joins the two strings together. So if I invoke concat on my first name and I pass it my last name, it's going to join in my first and my last name, just as I did as I ever to add them together, just like what I did here. So let me go ahead and compile and run. And here are my results. So the last method from the book to demonstrate is substring. The way this works is you pass in the index of where you want to start, and then you pass in the index of where you want to stop. So index 1 is I, because 1 is the second character in my first name, and index 4 is the A, because it's the fifth character in my first name. But you actually want to stop at 4 minus 1. So if we put in a 4, that means we're going to stop right before 4, right? So A is at index 4, so that means we're going to stop at C. So I should expect to see ICH for this substring. Now the next example, it's substring, but we're only passing in where we want to start. So we want to start at index 2. So index 2 is where my C is at in my first name. It's going to start at C, and it's going to give me the rest of my first name. So it's going to be C, then all the way to the end of my first name. So let's compile and run, and there's the results. So it started at index 1, which is the second character, I. Now the fourth character is A, so it stopped before A. And then the substring 2, it started at the second character and printed everything out after that second character.